Good morning, ladies and gents. Captain, this is your sailor man. I don't know, I'm not sailing, but never sail, never have. But I will one day, maybe. Anyway, let's. You seem to like my quantum videos because I had like 80 views on my quantum video. So let's do quantum again, because I'm actually really interested in quantum physics. I get it conceptually, but numbers-wise, mathematically, not at all. So, let's see what I don't know in simple words, but it's called, let me see, this video's, god damn it. This video is called Quantum Mechanics Explained in Ridiculously Easy Terms. So let's see what we got here.
In our world, things are usually straightforward and logical.
No, they're
The
not.
car is either at rest or moving.
Logical, I think not. Mentality-wise, maybe, maybe personality is that's the quantum of personality, the quantumness in how we think and how we act. Because it's not logical. It's not logical at all. And what if that's from quantum particles in us that make us not logical? Or maybe that's my excuse that I'm not logical. So, who knows? The world may never know.
The stereo is either on or off. A cat is either a dead or alive, one state or the other. There is no middle ground
Or comatose.
or a combination of states. However, the same can't be said about the world on the most fundamental level, on the scale of the most
Same can't be said for superheroes. That dude looks like a superhero.
basic particles were made of. On that scale, a particle doesn't exist in one state or the other, but in a number of states all at once. Like Schrödinger explained, a cat of the fundamental world would not be either dead or alive. It would exist between the two states, both dead and alive. This he called superposition, where a particle exists in a combination of states. Strange, right? But this is the strange realm called the quantum world, ruled by quantum physics. It has become quite a popular subject in recent years, and the bulk of credit goes to science fiction. The theories of alternate universes and time travel.
Science fiction. It's all coming true, man. Like, it's so. I couldn't wait for robots and like AI when I was little, and it happened. And aliens, it might be happening now. Who knows? The government might finally admit aliens. And now the quantum shit. Like, I don't know. I forgot what I was saying. Oh yeah. So this is the year that conspiracy theories come true. Cause they found out the CIA said they can't control the weather now. So who knows? Who knows what else is gonna be true? We're AI. We're the AI. Aliens were the real humans and we're the AI. How's that for conspiracy theory? Alright, back to this.
And the bulk of credit goes to science fiction. The theories of alternate universes and time travel are certainly keeping us entertained, but what exactly is
What's interesting is that the world kind of relies on sci-fi, and we strive to get towards what sci-fi made because the technology we have today, this has all been foretold in sci-fi. It's been all been like wanted in sci-fi, so we worked our way to it from science fiction, like 20,000 Leagues Under the Sea, and we're like, holy shit, it's a good idea. And we made what's it called? What the fuck? Submarines. How? Why did I forget that word? Anyway, back to
this subject that is feeding the world of sci-fi with so much great content? What is quantum physics? Quantum is a Latin word that literally means how much, but it is used for talking about the
How much physics, man? How much physics?
minimum amount of some physical entity. Aptly, we use it to represent the most elementary particles that are the basics or the minimum of this very
It's too quiet. There we go.
big world. So, quantum physics deals with the foundation of our world: the electrons in an atom, the protons inside the nucleus, and the quarks that build those protons, as well as the photons.
And an energy that we don't yet understand. That might be what we perceive as God. We mere humans think is God is an energy, like an ether of sorts. And then, like, that's why prayer can work because it sends out good vibes. It sends out the thought into the ether. And I don't know, that's my theory. Because when I was in a coma, and my mom said, like, we had a prayer day one day, apparently. And I might have said this before, I don't remember. But we had a prayer day. They had a prayer day where everyone, like, at 9 o'clock prayed for me. Like, everyone we know throughout the world, you know? So, that night, my right arm raised. But I know, like, a bunch of my friends, they don't believe in God. So I know they prayed or they sent good vibes. So I think the good vibes and the prayers kind of are good vibes. They travel through the ether, and I don't know. That makes sense to me. Back to this. Hey.
Photons that we perceive as light. These constitute everything that we are made of, both matter and energy. That sounds pretty simple, right? So how is this any different from regular physics? The regular physics is the physics that deal with Newton's laws of motion and its related mechanics. This is more formally called classical physics. This is the physics of our day-to-day lives, the rolling of balls, the rotation of the Earth, and the mechanics of engines. However, if classical physics is so wide-ranging, why was it insufficient? We must go
Not good enough for us humans, I'm kidding.
back in time to the 1900s to witness the birth of quantum physics. This was
Love the DeLorean. Love the DeLorean. And you know what? Apparently, people these days don't even get that reference. This reference.
a time when scientists were still unable to understand the observations of the photoelectric effect. Simply put, the photoelectric effect is a phenomenon in which light hits metal, resulting in the knocking off of electrons. According to normal physics, the electrons should start escaping the metal when the brightness of the light exceeds a sufficient limit. Yet, in reality, it was the color of light that determined whether electrons would be emitted or not.
Interesting. Very interesting, actually.
This was when Albert Einstein turned to Max Planck's equation. Planck's equation stated that light waves carry energy in small packets called quanta. This explained how each color of light had a specific amount of energy associated with its wavelength. This energy, in turn, was responsible for the electrons getting knocked off. Einstein used Planck's equation to propose that light not only acts as a wave, but also as a particle later named photon. Since then, physicists realized that regular physics simply wasn't sufficient to understand the microscopic world. They termed this regular physics classical physics, a physics of the past, and another branch of physics dealing with the fundamental.
Is that supposed to be an Ant-Man reference? Ant-Man or whatever. Let's watch this again. Because I started wondering if that's Ant-Man. Supposed to be Ant-Man. But I don't know. I didn't really see that movie. Well, I saw it once a long time ago. Anyway, let's watch this. They rewound a little.
Sufficient to understand the microscopic world. They termed this regular physics classical physics, a physics of the past, and another branch of physics dealing with the fundamental world as quantum physics. This world is therefore now called the quantum world. Let's be honest, our brains are made for this macroscopic world, where they can understand the running of a car on a road or the mechanics of a pen, but they are unable to initially understand the quantum world. For instance, imagine you're standing in front of a
We apparently understand it pretty well. Apparently, like as a study, we understand it well. But my thing is, how do we know we understand it well? Because it could be perceiving it wrong, or it could be like much more to it. So we think we so far understand it well so far, but not necessarily always. Back to our scheduled programming.
Massive wall and want to reach the other side. This wall is surrounded by deadly alligators, so your only
You can teleport through it. There's a non-zero chance you'll teleport through it.
options are either climbing it or making a hole through it. However, if you don't have energy enough to do either, you won't be able to reach the other side, right? Well, that's how the macroscopic world works. But in the quantum world, a particle can still go through such an energy barrier without sufficient energy.
Because that happens. That happens like with very minute particles. They pop up like in places.
This ability is called quantum tunneling. This phenomenon is responsible for the nuclear fusion that fuels the energy production of stars. As complicated as quantum mechanics may seem to some, it gets special love from popular culture. You may often see the dramatization of unusual quantum phenomena depicted in our macroscopic world.
Oh, that's supposed to be the Hulk. Okay. So yeah, this is supposed to be Ant-Man then. I don't know, that's Tony Stark or something. Alright.
Through movies and TV shows. Take, for instance, the Marvel Universe. Marvel movies are famous for their heavy use of quantum physics, at least the words, if not the actual physics. Even though most of it is fiction being labeled as quantum physics, there are some scenes that are based on theoretical concepts. One of these is the multiple realities of Doctor Strange. First, let's understand the quantum physics on which it is based. This subject deals with particles in terms of probabilities. For instance, while talking about the position of an electron, a physicist might say the electron is most likely to exist in this range of.
An electron is. No, I'm gonna do his voice. An electron might be anywhere. No, it's not his voice. That's like an evil guy's voice. An electron might be anywhere along this line. That's what he sounds like. Alright, back to this.
Lengths, say between 1 to 3 units. However, the same thing can be interpreted as electrons existing in different realities at different positions in the possible range.
That makes sense too.
So it can exist at 2 units in one reality, while at 3 in another reality, or any other possible number between its most probable range. In short, there are many realities covering each possible position of the particle. See mathematics and its implications again. A massive magnification of this concept. Mathematics.
Notice how the same particle can occupy. Did they spot occupy wrong? I don't think so. Let's see if they spot occupy wrong. I think it has 2 C's. Maybe I'm wrong. Let's see. Let's see. Hey yo, listen, ChatGPT. Is occupy spelled with 2 C's or 1 C? Uno se o dos se. Not incubus, occupy. Occupy. Let's see. Yeah, I was right. 2 C's. Fuck you, YouTube video. I love you, YouTube video. Don't hate.
And its implications again. A massive magnification of this concept is what
Hold
we see
so
in
what that said. Notice that the same particle can occupy different positions along the same line. This may refer to as different. Okay. Okay. I'm thinking about it. I'm letting it do a little. Okay.
Again. A massive magnification of this concept is what we see in Doctor Strange's multiple realities. Each possibility of a reality
and Rick and Morty
is a separate universe in itself, allowing there to be multiple universes. Another very famous use of this concept is in the beloved movie Endgame, specifically its idea of time travel. The movie understands that if we change the past, the future will also be changed. So, if
basically they're talking about any Marvel movie, like this is any later Marvel movie. I didn't see most of them, but the ones I have seen, this is basically the plot. Quantum world. Or maybe not. I don't know. I've seen Ant-Man and Spider-Man Into the Spider-Verse and Homecoming. And I think that's it. I don't know. There's too much. The reason I haven't gone into Marvel is because there's way too much. And I don't want to watch all of them, but I know I'll have to. Because I can't. So I don't want to watch. I don't want to get into it and lose my precious time that I'm wasting anyway. But I'm wasting time on many different like videos, YouTube videos and shit. But I don't want to waste time on like whatever. Let's watch this.
They all go back in time and kill Thanos. Who will bring about the
I
apocalypse?
saw
And
that.
why would someone travel back in time to kill him? This issue is called the Grandfather Paradox. A solution to this paradox was given by David Deutsch. Yes, that
Deutsch.
David Deutsch mentioned by Tony Stark in the movie. Deutsch said that the only way to remove this paradox is if we talk about the events in terms of probabilities in the same way we talk about particles. In other words, changing the past only has a certain probability of happening. That means that they might not even be able to kill Thanos in the past, probabilistically speaking. To sidestep this
Yeah.
paradox, the clever thing they did was go back and bring all the Infinity Stones back to before they were destroyed. Returning them to the same time would avoid any change due to the missing stones. One must admit that it was indeed a clever fix. Quantum physics has
Unless it's all multiple universes, and then whatever.
certainly fed a lot of fiction to the general masses,
This is still a good fix. So yeah.
but it has also become a necessary area of knowledge. It has assimilated itself into other domains of science and is still expanding. For instance, quantum computers are aimed at doing tasks that are too complex for a classical computer to perform. There is heavy focus on building a better communication system using quantum physics for better safety and privacy. Energy production via a nuclear reactor is only possible due to the study of nuclear fission via quantum physics.
Really? That I didn't know. I mean, I knew the fission part, but I didn't put that together with quantum physics.
It is also deeply ingrained into the subject of astrophysics. After all, the best way to answer the questions of the universe is if we understand its most basic building blocks. Regardless of whether we fully understand the subject or not, it is certainly growing in importance. With more talk of quantum physics to come, it is safe to say that it will soon become an integral part of our lives.
He guessed that wasn't me. Alright, so what have we learned? What have we learned from this video? Well, alright, so I learned that quantum physics is exactly what I knew it was. Weird as fuck. And I don't know. That's about it. I know that Albert Einstein was like he hated quantum physics, but I'm surprised that he discovered like he didn't discover, but he experimented with nuclear fission, didn't he? So I'm surprised that then if that's a quantum thing, then he did fuck with quantum things. Alright, so I'ma go. Alright, I'ma go. And like, you should like probably. And you should subscribe too. You should like, subscribe. And probably not share, because I don't see why you'd share this. But if you want to share, that's awesome. So, like, subscribe, and maybe share. And, peace. Where's this button? Alright, peace.